Okay. Well, it's been a minute since I've done one of these, so I guess let's just hop right into it. All right, give me just a moment. Monitor pulls up. Hopefully, right. Interesting. Okay. For whatever reason, my thing isn't working. Hold on. Properties. There we go. Okay, there it is. Okay. All right. Well, welcome to the stream. We are going over tomorrow's severe weather threat. We have a moderate risk out on the day two convective outlook from the Storm Prediction Center for March 2nd. This is covering a significant area of the Dallas Fort Worth metropolitan area. A lot of the eastern side of Dallas is underneath this. We are in the enhanced risk or the orange shaded region. That covers most of DFW, and then of course you have the slight risk in the marginal outside of that. The marginal risk covers Oklahoma, Oklahoma City, and Wichita Falls is under the slight risk. So currently, right now, there is a 15% chance for a significant tornado. That is what this little hatched area means here. This, of course, means 15% of seeing a tornado within 25 miles of any point inside the circle. That covers the eastern portion of the metroplex. In fact, that 15% of a tornado and 45% for a damaging wind threat is why we have a moderate risk in the first place. And then outside of that, we have a 10% risk for tornadoes. That covers the Dallas-Fort Worth metropolitan area. And then, of course, we have the hail risk. Significant hail is possible pretty much in all of the DFW area. Damaging winds, all hazards are possible tomorrow. Tornadoes, damaging winds, and large hail. The reason that it says tornado outbreak in the stream title is because it seems that East Texas, Arkansas, and Louisiana will be under a significant threat for a tornado outbreak. It seems to be mostly QLCS tornadoes or squall line tornadoes, but we could see a couple of storms pop up along the warm front, and I will get all of that into all of that in just a moment. But for the time being, I'm going to take you to an ongoing severe weather threat currently taking place in Mississippi and Alabama. This is a mesoscale discussion, so you can just ignore the blue boxes. Let's take a look at these boxes here. We have a couple of red boxes. In fact, we have a tornado warning for downtown Huntsville. This is expiring pretty soon. I think it might get extended, but we'll just have to see. And then down here, just crossing over into Mississippi, we have a line of storms that is tornado warned. And you can see here, if we turn on velocity, we have several areas of rotation. This is not the main focus of this stream, but I did want to acknowledge the fact that there is currently a severe weather threat ongoing. And, real quick, just before we pop away for just a second, they did in fact extend the warning. It is a radar indicated tornado and is currently, or radar indicated threat and is currently over Madison right now. We'll switch over to the Huntsville radar real quick and take a look at that rotation signature. It's just a little rotation signature right here, moving off to the east at a clip. So, back down to this particular storm here near Phil Campbell and Hackleburg. This is in western Alabama. You can kind of see a little rotation here, just south of Hodges. It is currently moving off to the east. So that is the main threat going on right now. Let's get into tomorrow's severe weather threat. So, like I mentioned earlier, we have a moderate risk in effect. Let's go over some of the model data real quick. So we're just gonna skip past this. It seems that a QLCS line is going to move into um, Alabama, but that is not obviously not the focus of tonight's discussion. Tonight's discussion is going to be going over tomorrow's severe weather threat, starting at about 17Z, which is 11 o'clock. That's when we're really going to want to take notice of any stuff that is going on. So, this is the HRRR, which is arguably one of the more accurate models out there. I do want to preface this discussion by saying I will be going over these models, but they are not, and they're not 100% accurate, and they are just models. So this is not a representation of what will happen. It's just a representation of what might happen. This is just a really advanced computer, and it is putting all of this math and spitting out these values. That's essentially what's going on. This is simulated reflectivity. This is simulated, so this is what could happen. But obviously the placement of these storms and even the timing is not entirely accurate 100% of the time. So that is something of note. So this is the HRRR model. We are going to start at about 17Z. We already have initiation forming. It should be noted that we do have what appears to be some convection, some rain going on down here southeast of the metro. This might inhibit the severe weather threat down there. This might make it not as strong initially, but as we get into the later evening, that might change. A couple of supercells might form here and there, but I think a lot of this rain is really going to choke it out. It's to the west that we really need to focus on. So, I should also, real quick before I finally get into this, I will also be discussing where I will be chasing tomorrow and how you can watch me chase. This will be the first official chase that I will be doing live streaming for Weather Tracker TV. You can find them on YouTube just by typing in Weather Tracker TV DFW. Make sure you put in the DFW. They have other areas around the country that they focus on, but DFW is the channel that I will be on. You can also find them on Roku and the Amazon Fire TV app, if I remember correctly. I know you can find them on Roku. I'm not sure about Amazon, but I think you can look it up in there. So I will be going over all of that as well, which is why I have Google Maps up, because I will be discussing my chase plans. So 17Z. Initiation forms just to the west of DFW and quickly moves off to the east at a steady pace, and you can see right as we get to about 20Z, which is about 2 o'clock in the afternoon, right around rush hour, we really start getting going. This is going to be a very significant severe weather threat. All hazards are possible. We could see tornadoes with some of these storms. I will mention that it's probably not going to be the main threat. These are mostly going to be hailers. So we could be talking about some very large hail, like baseball-sized hail, is possible with some of these storms. And they will be moving off in kind of a cluster, kind of a messy cluster off to the northeast towards the Red River. And then as we get later on into the afternoon, convection fires up to the west and starts getting into more of a linear or a QLCS. I've said QLCS a couple of times during this discussion. Essentially what a QLCS is, it stands for quasi-linear convective system, and essentially what that means is squall line. It's a squall line of storms. It's a line of storms. And so yeah, that's essentially what that means. As we get later on to the afternoon, things are going to ramp up fast, and here is where the main threat comes into play. This system right here, this line of storms. You'll notice these little bars right here. That is showing where the strongest storms are. That's showing where the updrafts are going to be, or where they could potentially be. So as we get into about 0Z, which is later on in the evening, about 6 o'clock, these storms are going to move into the Dallas-Fort Worth metropolitan area. All hazards are possible. A couple of spin-up tornadoes here and there. Some of them could be strong. Large hail is going to be possible with some of these storms, and damaging winds is going to be the main threat. This storm is going to move quickly off to the east and on into Louisiana and south, and well, basically into Arkansas, and it will keep moving off to the northeast. But Also of note, this particular storm system is also going to be bringing a lot of snow to the Panhandle, which is really weird because I was just up there on Sunday storm chasing, and there were several tornadoes up there, and now they're about to get a bunch of snow. It's just Texas things. So, heading off to the east, it moves out of our area by about midnight. About 10 o'clock. So I should know that we might have some rain wrapping around the backside of this, just a little bit of convection. That's not necessarily going to be a big deal. Just might be some rain. But pretty much after about like 10 o'clock, 9 o'clock, 10 o'clock, the threat will be over. Might get some light rain on the backside of this, maybe some lightning, maybe some thunder. But other than that, it's going to be relatively quiet for the rest of the evening. Let us check out the NAM model, or the NAM, starting at about 0Z. This is significantly later. Wow. It shows a little bit different. This is the problem with models. I did say that the HRRR is a fairly accurate model. In fact, it's one of the most, it's got to be one of the most accurate models out there. That does not mean that it's right 100% of the time, but it is one of many tools that storm chasers use while in the field. And so is the NAM, but the NAM is a little weird with timing sometimes, but this shows roughly the same scenario, just a little bit different timing. Instead of convection really getting going at about 17 Z, or I keep saying 17Z, or at about 11 o'clock in the morning, instead of convection really getting going about then. Well, actually, I take it back. It's pretty accurate. Yeah, 21Z, storms start entering the metro. Yeah, it's about an hour off, so I take it back. It's relatively accurate, and it's pretty much in agreement with the HRRR. Storms move off on a clip to the northeast, and then by about 6 o'clock in the afternoon, we have or 6 o'clock in the evening, we really have a line of storms going at about 03Z. This is where the difference really starts to come into play. It's still moving through our metro at about 9 o'clock or 03Z. Went back to the HRRR, but relatively the same scenario. This goes in 3-hour increments, so that's why it looks it looks more jumpy than this. This is hour by hour. This is a little bit more jumpy than that. But about 06Z, which is going to be well past midnight, it's going to be about 1 o'clock in the morning. It basically exits the state and moves off to the northeast, still producing QLCS tornadoes along the way. This is going to be a very powerful line of storms. And then it's roughly the same story, and then it's quiet for the next few days, so that's good. This is the NAMNST, or the NAM Nest. This is a little bit of a higher res model, and it shows pretty much the same thing. 17Z, we have convection pretty much in the same area. These models are in relative agreement, which is good for storm chasers, not good for people living in these areas. So these will be moving off to the northeast, and a little bit of a different scenario about 21Z, which is when this line started to get going off to the east. It doesn't really show the same thing, but it does have this cellular cluster moving through the Dallas-Fort Worth metropolitan area, and a little bit of a later start at about 01Z, which is going to be 7 o'clock or 1900 for those who are used to military time like me. Pretty much at about the same time. 02Z is still moving through our area, but it exits the area at about 04Z, which is 10 o'clock at night. So it's kind of in agreement. The only big difference between that and the other models is the initiation start time. And the setup is a little bit messier on this one. You can kind of see it. It's more broken. And then it kind of gets its act together and exits. So, let's kind of go over more of a up-close, high-res look at what we could be seeing tomorrow. This is going to be using the HRRR again. I am using a different app, Pivotal Weather. Also a really good service. However, unlike COD, it is paid. So you do have to pay to use some of the better features. And the better feature in this instance is the zoom. I get to look at a more local level. This kind of looks at a more regional level. So we'll really get down into the thick of it with this one. And it's pretty much the same thing. Pop-up storms and supercells going off on the northeastern clip at about mid-afternoon, and then it goes through the area and forms kind of a convective system at about, and kind of really exits our area at about 9 o'clock, and then it's gone. I'm also going to be bringing up a longer range model because I do think we have some more weather on the way. In just a couple of weeks, we are entering a more active pattern. This model isn't so much accurate, but I do want to give complete fairness to all models. So we're going to be looking at this. This is also in 3-hour increments, so keep that in mind. And as we get into tomorrow at about 21Z, pretty much the same story. Storms really start moving off on the northeastern clip. These are going to be these prefrontal cells. Essentially what a prefrontal cell is, I mean, it's exactly as it sounds. Before the front moves through, which this squall line is going to be part of the front, there will be a cold front moving through, and I'll show you more of that whenever I go back to the models in just a moment. But these cells are going to be prefrontal, so they're going to be forming ahead of the front, and then they'll kind of get choked off as this line really starts getting going as it moves through. So all the models are pretty much in like similar agreement. They might differ a little bit in timing, and maybe in strength of these storms, but it's relatively the same story. For the purposes of this discussion, I'm going to stick with the HRRR model, but yes, again, it is not entirely 100% accurate, and some things may differ tomorrow. The timing may be different, or the entire event could bust. You know, that's always a possibility. Sometimes just stuff doesn't happen. I can't tell you how many chases I've been on where like it's looking like it's going to be a really good event, and then it just falls apart. It doesn't look that likely with this event, but it's been, very well forecast, but, we'll see. To be honest, I would prefer supercells not moving through a populated area, especially at rush hour. That is kind of especially when they could be potentially tornadic. That is not ideal. So, let's kind of get down into the dirty with the meteorology here. We're going to be looking at CAPE. Now, what essentially CAPE is the measure, put simply, is essentially the measure of energy in the atmosphere. Storms need energy. They need moisture, they need instability, and this is basically all of that. And I mean, it is pretty much the same. This hatched area, this covered up area, is the cap. And as you can see, we really don't have much of one. It breaks pretty easy. This is going to be surface level. If you know what the cap is, it's essentially a layer of stable air kind of high up in the atmosphere, and it is the number one killer of storms, particularly here in the South. If you have a cap and it is strong enough to stay in place, you don't get storms, because storms, by their nature, they push up, and they push up. Their updrafts are what drives them, and they're called updrafts, and they push up. They need to get higher up into the atmosphere in order to really get going, because once they get high up enough, they will eventually start to tilt, and that's what makes a supercell a supercell. That's what delineates supercells from other storms. Other storms kind of just go up. Their updrafts form like they just go straight up. You'll see this in the summertime, especially here in Texas. We'll have these pop-up storms, as they're called. They'll go up. Their updrafts will form, and then eventually, as the storm gets strong enough, the rain will come in on itself and start choking the storm off, and then eventually the storm collapses in on itself. But if you can tilt that updraft, if you can get the updraft strong enough, you will have a longer lasting storm. And supercells can go on for hours, and they can cross multiple states. But a cap will kill all of that. The problem is, with this severe weather event, we don't have much of a cap in general. So that is really going to be a detriment as we get. If you don't want severe weather, you want a cap. And we really don't have much of one. This cap is going to be relatively easy to break. It's not 100%. It could hold, but it's not super likely. It's pretty weak. So it would take nothing short of a miracle for the cap to stop this system, but it's possible. It's always possible. So, CAPE, energy. We have a lot of it. And then as you kind of see, it kind of exits our area with the squall line, which is what you want to see. You don't want any of that cape sitting around. We're going to look at the significant tornado parameter. This is still on the HRRR. This is basically a measurement of a bunch of models within the HRRR, because you can see you have temperature and all of that. This is a bunch of ingredients mixed together to show you where the most likely area a tornado will happen. This is not the most accurate model, but it's, for the purpose of this discussion, it is a pretty good illustration. So keep in mind that 17Z time frame, 11 o'clock in the afternoon, you have initiation over here, and then as we get later on into the afternoon, the tornado threat begins to increase. And then as the squall line begins to push through, we have a spin-up tornado threat, which is what this is probably going to be. Again, it's not completely accurate, but it is a good representation to show where the main threats with this line are going to be. And as the squall line pushes east, we'll go back to our precipitation. We'll go back to our simulated reflectivity. As this line pushes east, it's going to get into a better environment. Remember, this moderate risk is kind of centered over eastern Texas on into Arkansas and Louisiana. As it begins to enter that area, it is going to enter a better environment for tornadoes. So it seems like the biggest risk for a tornado outbreak is going to be out here in the eastern part. But keep in mind, we could have tornadoes here in DFW. We are in that 10% threat. That's pretty high. There could be at least one tornado within this entire area, so it is important to keep that in mind as we go through it, through the rest of this discussion. So let's go back over here to our convective. Let's show updraft helicity. Helicity essentially means spin, and this is going to be updraft spin or strength, essentially. That's what I remember correctly. That's what helicity means. I'm not a meteorologist, so you can't, like, there are stuff I'm probably going to get wrong from time to time, so please don't yell at me in the comments if I screwed it up. Yeah, it's spin. Helicity is spin. So, as you can kind of see, we've got a lot of spin. Remember that 17Z time frame? We really get storms going out here in, south of, it's not Abilene. It's, well, it would be nice if it would load. There we go. Yeah, Abilene. Okay. South of Abilene, along I-20. And then as we get it later on to the afternoon, we really get going with these storms. It seems like a lot of the biggest tornado threat is going to be kind of in this general area to the northeast of the metro. We're going to go over to National Weather Service Fort Worth as well. I probably should have loaded this up earlier, but I want to include their discussion of this. And then as we get later on into the evening, that's where that squall line comes into play. And look at those updraft helicity values. These are going to be some embedded supercells within the line, and those are going to be the ones to probably produce tornadoes if they do happen at all. I do not think that this will be a tornado outbreak within the DFW area itself, but it is certainly not out of the realm of possibility that we see a couple of tornadoes throughout the day tomorrow. And you know what? It could be classified as a tornado outbreak, but we're just going to have to see. Be on the lookout, essentially. All hazards are possible tomorrow. Excuse me. All hazards are possible tomorrow, including tornadoes. So you should definitely be on the lookout for that, because these storms could get ugly real fast. You definitely don't want to be caught in rush hour traffic in the middle of all of this. So please take this seriously. So there is that. We'll also look at lightning density just for fun. There's a lot of cool stuff you can do with this model. Remember that's 17Z initiation down here near Abilene, and as it moves off to the northeast, look at those lightning values. We're gonna get quite a lightning show here in DFW for sure. If you like to sit out and watch storms, as long as you aren't standing out on your porch in the middle of a tornado warning, its QLCS lines are particularly interesting with their lightning production. It's quite a sight to behold, especially on the back end of these lines. You will sometimes see what we call anvil crawlers. So right here you've got the thunderstorm on the back. You've still got rain falling on the backside, and it's still technically a thunderstorm. So you'll have like lightning crawling like underneath the clouds. They don't really make contact with the ground, but they'll sit there and just crawl out, and they'll stretch out for miles. It's quite incredible. So, yeah, that is pretty much the end of that. We'll go over a couple of other things. Temperature. That's what I wanted to show. We're gonna kind of show this cold front. Temperatures are going to be pretty high tomorrow. They're almost going to be in the 80s, it looks like. And then as we get into later in the afternoon, can you spot the cold front? I can't imagine where it might be. As this thing moves east, it's going to bring some chillier temperatures down into the lower 40s. But we'll quickly rebound. Dew point. This is going to show how muggy it is outside. This is the humidity, and oh boy, look at those values. You've got 70 degree dew points out towards the southeast of the metro, but 60-degree dew points here in the metro. So it's going to feel a little muggy tomorrow. It's probably going to feel like it's in the upper 80s. And then as that line moves through, bye-bye moisture. So, relative humidity, we'll show that as well. Yeah, roughly the same values. It's going to feel really muggy tomorrow, and then boom, it's all gone. So, let's go over what my chase plan is for tomorrow, just because, you know what? Why not? So, like I mentioned, the plan really is going to be sticking to the west of the metro, because that's where a lot of the initiation is showing. And it seems pretty consistent in that regard. If I go back to the 18Z and pull up, I think it's roughly the same. Yeah, it's a little bit different, but it's still showing that convective convective stuff, all of that rainy mess down southeast of the metro. And then, hey, there's our storms. This particular run shows storms to the southeast. That is still a possibility. We could see storms to the southeast of the metro, as a lot of this early morning rain clears out. So that is something you should be on the lookout. That is certainly possible. But I think the biggest threat is not just going to be these supercells. It's going to be that. It's going to be that QLCS line. It's going to be that squall line. That's going to be the biggest threat. Let's look at cloud cover real quick, and it's overcast. Awesome. We love to see it. We love to see overcast skies before a severe weather threat. That may help inhibit the severe weather threat. Daytime heating really helps that, but I guess we'll just have to see. There might be enough breaks in the clouds to the point where it doesn't even matter. So that's roughly it. Let's go over the chase plan. So plan is to leave at about 10 o'clock in the morning and just head out west and sit and wait. Just going to sit and wait. Just going to see what happens. If storms really start firing to the south of Abilene and start moving off to the northeast, we're just going to, we'll be hitting along these areas. Probably going to stick to the Weatherford area. We're going to go down to, Granbury, Stephenville. This general area is going to be our stomping ground for the day, if the models are right. If not, I may completely screw to pooch and miss supercells here to the southeast of the metro. That's entirely possible. I guess we'll just have to see. I hope to God not. I hate missing supercells. But that line is really going to be worth it. So worst comes to worst, we miss the supercells. We'll just go back east from this area, and kind of stick to the south of the metro where there aren't, buildings and trees, and we'll just sit and wait for that squall line to get going and see what happens from there. So that's pretty much it. Y'all stay safe tomorrow. I will, like I said, be live streaming on Weather Tracker TV. I will be trying my best to keep consistent coverage on that, but I make no guarantees. I may not be streaming all the time. On there. You'll just have to pop in on that stream occasionally and check and see what I'm doing. So I really recommend you guys go check that out. They do consistent coverage, and the lead forecaster is really cool dude. I've been talking to him a lot, and he seems really cool. So I think y'all might like him if you go and check it out. Can't highly recommend that enough. They are a really legit program. And I'm not just saying that because I technically work for them. They really are. They're a fantastic group. So that's going to be about it, ladies and gentlemen. I'm going to end the stream here.